Hi, I'm Rahul Veer, and I'm here to talk about a subject that I get very passionate about, connectivity fault management, and how it applies to protection and fault recovery at peering points. Funny incident, a few days ago, I met one of my friends. This early in the morning, and he looked very tired and looked he hadn't had any sleep. So I went ahead and asked him, what's keeping you awake? Is your network all right? And he said, yeah, my network's all right. It's just my customer is losing my end-to-end connectivity, and he keeps calling me whenever he loses it. And the problem is that there's some other operator that has an issue, but I have no way of telling him that my network's right. So it becomes very important, besides protection and fault recovery, that we give a way of verification for the customer that the network's working, and I'm providing the SLAs as I told you. So, sure. Hopefully that's better. Okay. Basically what I'll be covering is what are the challenges that people are facing at the peering points, both from the service provider and IXP perspective, and the current OEM options that are being used. And then I'll directly go over after that to connectivity fault management and see how it's used, and then give an example of that. And then it should be about 3 to 5 minutes for Q&A at the end. So among the major challenges, the potential issues that could happen are at the fiber level. There could be a fiber cut or electronics failure, a card failure, or node failure. Besides these issues, there could be, if you're using OEM tools which are not designed to go through the exact data path, they could lead you astray, and they are not very useful. And the third thing is, which, for example, of my friend, it's difficult to separate the exchange point issues from peer issues, and that becomes very important. If you want to know more about the issues which are not really relevant, that's why I didn't bring it here. So those are there in the peering forum website, which you can go. So the desirable features of OEM tools are basically, if you're providing a very critical link and you want to be able to make sure that it's always active, you want to have a proactive method of checking the link all the time, and continuity check usually does that. And in many cases, you have a layer 3 network, but you're going through a layer 2 network, and you have no visibility within the layer 2 network. It looks like just one hop. So providing that visibility becomes important in this case. And another thing is that when you have going through various operators, sometimes you cannot get visibility, especially when it's layer 2 network, you get no visibility into the other operator's information. So having some visibility in that is another challenge. So you need OEM tools for when you are actually setting up the network and testing it. And then also when you have a network, it breaks down, and then you want to, on a fault, you want to troubleshoot it and figure out what's wrong. So going directly to what are the current options being used, there's ping and trace route, of course, at layer 3, and then there are proprietary methods like UDLD, which will give you information about a link, and whenever a link goes up and down, you'll know. And then BFD can be used for one-hop BGP. So if it basically can be used if it'll give you an advanced indication, a very fast way of detecting a BGP went down. And then there's proprietary layer 2. So here's an example of how you can do UDLD, and it tells you, like over here, it will tell you how many transitions happened up and down. It will tell you the remote MAC address and the current state. BFD provides you information about the neighbors. Just want to quickly skim over this because this is not the main discussion topic. The next one is layer 2 trace. It's another proprietary way, but it gives you very good information about layer 2 network. So in this particular example, we are doing VLAN 10, and it tells us that there are 2 paths, path 1 and path 2. In path 1, you can go out this interface, and then there's one hop. That's the next hop, next node, next switch, and it'll tell you information about the MAC address and IP address. And if it's just there's no IP address, it'll only give you the MAC address. And path 2, it has 2 hops. So this is what's being used currently. Now, connectivity fault management, which is the main topic today, it's it's IEEE 8021AG, and it's a standard for detecting and isolating uh, connectivity faults in a network. What it provides is it provides for a nested maintenance domain. So you have an operator domain, and within an operator has full visibility over the network. And then you have a provider using that network, and he can use that for end-to-end OAM mechanism, but he can get some restricted visibility into that particular network. So it can actually cross various administrative boundaries, which is not very common for layer 2 OEM mechanisms. So what it provides is it provides path discovery, fault detection, verification and isolation, notification and recovery. And I'll once we go over the various methods, then we'll come back to this thing again. So with this diagram, we can see that we have a provider domain, and so there are maintenance domains in connectivity fault management. So in CFM, there's a provider domain over here, like it's seen, and the provider has it's his own operator, so he has all information about himself. But the customer domain, which is the domain outside and which encompasses the provider domain, has end-to-end connection over there. So if you have for the customer, you have the green ME, and the endpoints are the triangles, and the intermediate points, the maintenance intermediate point and the maintenance endpoint. So intermediate points are the circles. So it can, from one endpoint to another endpoint, it can have a maintenance entity, and that can generate messages, which could be for connectivity or loopback or link trace. Similarly, for the provider, his network goes from his maintenance entity is the orange one. So his endpoints are right ending at the endpoint where he is connecting to the customer. So within a maintenance domain, you can have maintenance associations where you have like multiple VLANs, could be multiple maintenance association, and each maintenance association is associated with a service. And you can have multiple levels. In this particular case, we have provider domain at one level and the customer domain at another level. So there are 5 basic messages in the CFM. The packet format is like a simple Ethernet packet with a special Ether type of 8902. And it has one message for CCM, the continuity check message. There's a loopback message, which is just like our ping at layer 3, but this is at layer 2. For loopback message and response, and for link trace, there's a link trace message and response. And the packet format is like this, and this by the opcode you could differentiate the messages. So in continuity check, its method is a little bit different than some other mechanisms. So let me explain you a little bit. What it's doing is it's sending a multicast message. So if I am an MEP, I will send multicast message to all the other MEPs in the network. So when and I'll similarly receive messages from other MEPs. Now this is a discovery mechanism, so I can see all the MEPs in the network once I have received these messages. And the messages could be very fast, depend if you want a faster link up down, or if you want to slow it down because you want to reduce the load on the network, you could reduce the speed of the messages. Now what this gives is that it gives me a link, the status of my link all the way to the end. So it's end to end. I can measure if the link is okay or not. And if the link, if there's some issue, either I'll miss a continuity check message, or there could be a remote defect indication bit is there in the message. So if one of my neighbors is not having some issues, he's going to actually send that RDI bit to me, and then I will discover that there are issues in one of the endpoints that are connecting to me. So it's very useful for detecting any failures or any other issues like misconfigurations that could happen. In the loopback operation, again, in this particular case, the message is actually a unicast destination MAC address. It's destined to the destination which we provide. And the MEP actually sends this message to the destination MAC, and then the destination could either be a maintenance intermediate point or an endpoint. and it sends a response back, and it's very similar to a ping message at layer 3, but this works at layer 2. Link trace message, again, the parallel at layer 3 is trace route. What this does is, if you send from a maintenance endpoint, if you send a link trace message, it will go to the MIP. The MIP will do two things. One, it will respond with a link trace response about sending its own information, and the second thing it's going to do is it's going to forward it out to the endpoint, and when it reaches the endpoint, that's where you're done. It sends the response back that we have reached the destination. So this provides you the full link trace. So coming back to the four things that I had shown earlier, the CFM tool provides us with path discovery. That's using the link trace protocol. There's fault detection using the continuity check protocol. There's fault verification and isolation using loopback and link trace. And then fault notification happens whenever we get a continuity check, either it's an error or we miss the messages, the MEP will actually figure out and then issue an alert. So it helps us figure out connectivity at layer 2, and whenever there is an issue, it will quickly issue an alert, and providing full visibility into the layer 2 network. And it helps improve the SLA to the end customer. So the advantage is that when we are telling to a customer that, my network is up, you can prove to them that the network is actually up. And this is one example where we can see all the things that we discussed just now. So in this particular example, I've taken a very simplified approach for us, for the purposes of time. In the IXP maintenance domain, I've configured that as level 4, and then level 7 for the ISPs. And when the ISPs are connecting, they are at level 7. We have the maintenance endpoints at each ISP. Let's see, yeah. And we have the maintenance endpoints over here and the maintenance intermediate point right over here. So there's no visibility in the exchange providers network except at the very edges. However, at layer 4, which is within the operator domain, it has full visibility through all the nodes in the network. Because in case there's an issue, you want to figure out exactly at what point it happened. So MEP will generate alerts whenever there's a connectivity fault detection, and then both ISPs and IXPs. So there's from MEP to MEP, but both the maintenance entities, we have a continuity check running. So both will know whenever there is an issue, and they'll figure out, and then they can use link trace and loop back to basically isolate and then verify the problem. So yeah, I don't know if the font is very small. Let me read it out a little bit. So if you do a show CFM on one MEP, it will tell you the maintenance level at level 7. So at this particular router, which is router A, we have only one level, that's level 7, and the MEP, which is the number that we assign, which number is 22, and the direction is down. This is not the operation or the admin state. This is the direction as defined in 802.1ag. And what this basically means is that a down direction is if we are sending messages this way and it's directly going to the wire from the switch. So that's a down direction as against an up direction, where in this particular case at 4 MEP, it's actually going to the switch fabric and then going to the wire. Sorry. So this is down direction, and it says, okay, this is my local MAC address and my local port. However, if I look at show CFM connectivity, it'll tell me about the remote, and it say the remote MEP is 23. Now this is something that we discovered through the messages. My remote MEP is 23. I know the remote MAC address and the VLAN, and I get all that information right to me through the CCM messages. If we do link trace basically will say link trace and provide the maintenance domain, maintenance association, and then we'll say source MEP is 22, target MEP is 23. So we are going from this point to this point, and we'll say the response would be from the first node. We'll say egress 81. Next node would not be this node because there is no MIP in this one. Next node would be this one. And the egress is 4.1, and then it reaches the destination, where the ingress, and it says, okay, it's a hit, which means that it's reached the destination. And the loop back message is, that's very similar. It's basically saying source MEP to remote MEP, and it sends 10 messages and gives you the return time. If you are in the exchange provider, if you are exchange provider, the view is a little bit different because you have two levels now. You have a level 7 here, and you have a level 4 here. At level 7, you have only one MIP, the green one, and that's the information. And then you have, at level 4, you have one MIP, which is 1. That's the number we configured. And then the remote will be 2 if you look at that command, and I don't have that command over here. And then there's one MIP locally, that's 4 over here. So you can run a continuity check over here, and you can keep the continuity check message, the time difference, to be low if you want to detect before others. And the link trace, in this particular case, it only shows 2 hops, and it'll show, if you go from here, it'll show, okay, egress and 5.4, and then destination of switch C, E72, 5.4 and E72. And the loop back is very similar to the previous one. So after looking at all these, the various options that we use today, and comparing them, how does they stack up against CFM? In this particular example, there's fault detection and isolation. We have 8021AG provides both. BFT provides a good method of fault detection, but isolation, it doesn't do any of that. At proprietary UDLD will provide you at fault detection at link level. Proprietary layer 2 trace protocols, the example that we looked at, provides us fault isolation, but there's no continuity check over there, so it doesn't provide any way to detect it. Ping and traceroute will provide a method of isolation and verification. The next one is standards-based. 1AG and BFT and IP ping traceroute are standard-based. The proprietary protocols, I've marked them as proprietary. Visibility into layer 2 networks is very important for this particular case, because here we are going through another operator's network, and we have layer 2 visibility, maybe a little bit restricted, and that's by design, but it provides layer 2 visibility, and we can configure any level of layer 2 visibility, because the protocol provides us with various options, and depending on the policies of the operator, you can increase or restrict the visibility. So proprietary layer 2 protocols do offer that, but they are proprietary in nature. Layer 3 visibility will be in layer 3 protocols like traceroute, and then all of them work over all the Ethernet interfaces, 10.100 all the way to 10 gig today, and they work over link aggregation groups. And the last point is actually very important. It provides so OEM domain separation, and in that it is providing us the ability to restrict the visibility, which is what we discussed earlier. So that's something that other options out here don't provide us. So that's one big advantage for CFM. So looking at basically summarizing what we discussed today, it's a single OEM tool that provides us path discovery, detection, verification, and isolation all together. And the advantage is that if we can discover a problem very fast, it provides us, it improves the SLA. Like in my, the example I gave for my friend, if he had a way of telling that, okay, I can show you the continuity check on mine, or you could run a link trace and it goes all the way to the end of my network, then he could basically get out of the thing because it was not his problem. And again, it helps in providing a way of separation of exchange point issues from peer issues. Nested domains provide ability to restrict visibility into another operator's network. And then the final very important thing is it's standard based, so it avoids any vendor lock-in. So I think we have enough time for Q&A. Yeah.
Do we have MIBs, SNMP MIBs for?
Say again?
Do we have SNMP MIBs, MIBs?
Yes. Yeah, so there are various ways of sending alerts. So one is through, you could either do syslogs, and then SNMP MIBs can be used for alerting that as well. Yes. Okay, thank you.